So basically in our lab 9, basically we were asked to build a multi-threaded processor. So basically a design was given to us where we'll be using a multiplexer to choose between PC1, PC2, PC3, PC4 and so on. And at the same time we'll be having a register file. So basically there were two options to derive a register file. So we can have a register file, have a single register file which will be giving a slot, for instance 0 to 31, then 32 to 63 and so on. Or else we can define four different register files and accordingly we can use it. So basically in a particular thing we have used four different register file for our multi-threading operation. So basically we were asked to implement a four thread processor, so for which we defined four register files, and accordingly I will just go through the block diagram one. So this was the block diagram which was provided to us, and accordingly we changed some of the contents of the code and we implemented it. So I will just show you what kind of code that we modified and will walk you through the simulation as well. So in the pipeline, yeah, pipeline.v. So in the pipeline.v, what we did is, what I personally did is, instead of, as we know that basically on basis of the input, that is suppose we have an input called thread select, which will select which thread is going to perform, for which will be a 2-bit signal as it is four threads. So basically what I have used is, I have used case statement which will select which particular thread to select, and accordingly to which register file we should drive the value, and in which register file we should perform the values with. And accordingly in the same time we'll be using the PC as well. So for instance you can see here that case statement, I have given case statement here, that for 00 PC0 will be there, for PC1, PC2, PC3. For instance here I have commented it out because I was doing various kind of simulation, so I have just commented it out. At the same time which particular register file we need to use. So basically here there is another case statement I have written down, which will select a register file and accordingly we'll be getting value from the register file. So these were some of the changes that I made. And also at the end, when we will be using the write back operation, like from the fifth stage, what I did was, we know that the address and data which it is something that will always be coming. So instead of modifying that, what I did is, I have drive the enable signal and I am driving the same address and data to each of the inputs, but only the enable signal will distinguish which of the operation we need to perform. So these were the three major changes that I did. So basically I will just walk you through the simulation. Before that I will just walk you through the test bench environment that I have created. So here state FIFO is 0, that is state FIFO was nothing but basically whenever our particular FIFO, basically our DRAM was used as a data memory or either as a FIFO, right? So basically state FIFO was declared as 0, that is it will do a normal operation. And you can see that here thread select is equals to 0, that is it will select the first thread, that is register file 0. So in the simulation what we should observe is that a register file 0 should be modified accordingly, and register 1, 2, 3, 4 shouldn't be changed. So you can see that in the simulation part I have done the simulation as well. So basically we are doing some loading operations which will tell which of the register file is getting updated. So you can see here that in the register contents are changing, right, from 110, from 0 to 110 and so on, and here it is getting 5. So this is how we know that register file 0 is getting changed. In the same way if we, here in the test bench environment, suppose for instance here, instead of thread select 1, if we give thread select 2 1 for instance, and we'll rerun the simulation. So you can observe that the register file 1 will get updated instead of 0, 1, 2 or 3. So I'll just rerun the simulation so that you will get to know which of the following changes. And also we tried doing various operations as well, like the basic operation like load word, show word, accordingly for each of the register file, and we tried using running various kinds of commands as well. So if you can see, it is register. Okay, just a minute, I need to add it. So here is register. Okay, I need to rerun it. So basically what we should observe is that register file 1 should get updated instead of register file 0, 2 or 3. So we get to know that multi-threading is performed and thread 1 is selected and it is getting updated. Register file is getting updated accordingly. So this is a normal register. So at first we were seeing some of the changes, right? So now you can't see any changes in the register file 0. But if now you can see register file 1 that we have added now, so you can see that same changes will be seen in the register file 1. For instance, like I need to change some of the values, it seems, the simulation environment, but it changes. So we can see that accordingly the register file gets updated as we select the different threads.